All right, good morning. Happy Straight Line Tuesday to my Algebra 2B class. Unfortunately, there's no straight lines to be drawn here, but I want to jump back into the natural logarithm. So e in the natural log. And again, e is just that irrational number, and if you watched the Khan Academy video yesterday, you know that that value is about 2.71828. E often occurs as the base of exponential and log functions that describe scenarios in nature. You'll see things like the spirals in a sunflower or in a rose, or the way that certain animals build their habitats. For whatever reason, E just shows up everywhere in nature. And we call these exponential functions with a base E. We would call those natural exponential functions. So, like y equals 2e to the x minus 1 plus 3. And we know that the transformation, the shift here, we would shift right 1 and up 3. So there's another bit of review for our Algebra 2 class. I do think those transformations are very important. Obviously, we've done them all year. But I think it's one of those things where if you know it for one, you know it for pretty much all functions. And for that reason, it's important to get a solid grasp on it. And logarithmic functions with base E, like we said earlier, are called natural logarithms. You can be written as log base E of 27, or ln of x, or ln of 27. So just like when we write log base 10 of, 3, well, we almost never write that 10. We'll almost always write log of 3, and it's just understood that that 10 is hiding here, since we live in a base 10 world. All right, I'm going to do several of these to get, we'll do, maybe the first 2 of each. For these down here, I'm only going to do the first 3 of each, just to keep this video kind of short. Now, again, we're going to write these in logarithmic form. So we're going to end up with log, and we're going to write it out the long way first. So log, and what's the base of my log? Well, what's the base of my exponent? Log base E of what equals what? Well, the exponent always goes out here. So log base E of 24 equals x. And we could also write this as the natural log of 24 equals x. Because again, that natural log just means the same thing as log base E. So let's do this next one here. Log base what? Well, what's the base of my exponent? Is E. Log base E of what equals what? Well, the exponent, where does the exponent go? Exponent goes out there, which means x must be in there. So natural log of x equals 9. So why don't you guys write out this last one here. Don't worry about simplifying in any way. I just want you to write out your logarithmic form like this. All right, and that would be natural log of 72 equals x plus 5. And I just want you to leave it like that. All right, and let's try this one here. So again, this is log base e of x is 58 is another way to write that. So we're going to write this as an exponent. So what's the base of my exponent? Well, what's the base of my log? That would be e. Where does my exponent come from? Well, here the exponent went on the other side of the equal sign. So e to the 58 equals x. Same thing here, log base e of 6 equals x. So what's the base of my exponent? Well, the base of my log is e. So e to what power? Well, that exponent is always off to the other side of the equal sign. So e to the x power equals 6. And why don't you guys pause the video, write out number 6 here, and don't worry about simplifying or solving for x or anything. Just write it out as an exponent. So this is log base e. So e to the exponent always comes from here. 32 equals x minus 9. Okay, now let's get a couple of simplifying properties back in our head. It's been a little bit since we've done one of those. So if I'm adding two logs with the same base, what do I do with the numbers within the logs themselves? What operation goes with adding here? That would be multiplication, so natural log of 3 times 16, or the natural log of 48. All right, well here we've got a little bit different scenario. We've got subtraction, but we've also got a number out front. And what do I do with that number out front? So maybe if I add, 3 log of 7. 3 times the log of 7. What would I do with this 3 to get it to move inside the log? Well, I'd bring it up here to the exponent. So 3 times the log of 7 equals the log of 7 to the third. So here I'd get natural log of 63 minus the natural log of 3 squared. And what operation is going to go with subtraction? What am I going to do with these two numbers within the natural log? Well, if I'm subtracting, then I'll divide. So I can write this as natural log of 63 over 9, or 63 over 3 squared. And you know what? I'm not going to worry about simplifying for right now. We could and get the natural log of 7, but that's really what I'm concerned with right here. So why don't you guys look at number 9. I want you to get rid of these numbers out front, bring those into the log, and then simplify. And we would have, pause the video right now and unpause and check your work in a second. We would have the natural log of 4 plus natural log of x squared equals natural log of 4x squared. So 64 to the 1/3. The cube root of 64 is 4. And then bring that 2 into the exponent. And I'm going to leave those last two. Don't worry about 12 for right now. I'm going to leave these last two for you to do just to keep the video short. But let's work on solving some exponential equations. Okay, so I want to get the exponent by itself. And what do I need to get rid of to get this by itself? Well, that 3's got to go. So I can divide by 3. I can divide by 3. And I can get 10 to the x plus 2 equals 7. And then our next step here, so that's step 1. Step 2, we need to get rid of this exponent. So we can write this in logarithmic form. So we can write this as log, what's the base of my exponent? It's 10. The exponent always goes off to the right. And seven's going to go in the log. So what we can do now is we can simplify this. We can evaluate that log in a calculator and get 0.85 approximately equals x plus 2 and then we can subtract the 2 to get x equals negative 1.155, about negative 1.15, somewhere around there. So our first step will always be to get the exponent by itself. That'll be the first step, and the second step will be to write as a log and then simplify. So I'll do the next one. I'll do 13 and 14, then I'll do 19 and 20, and I'll cut the video there. I'll post the rest of these later just to keep the video short, or I guess as short as I can. So I want to get the exponent by itself, so I'll get rid of this 0.5 by dividing by 0.5. So 10 to the 3x equals 34. Again, that's our first step. Second step is write this as a logarithm. So log base what? Well, the base of my exponent is 10. So log base 10, or just log. Exponent always goes out here. And now let's figure out what is the log of, what is the log of 34, or log base 10 of 34? Log of 34 is 1.53 approximately. And then to get that x by itself, I can divide by 3. I can get x equals, divide by 3, and x equals 0.51. All right, let's do these last two and then we'll cut the video. So same process, same idea. I want to get this exponent by itself. So I need to get rid of the 3 by dividing. So e to the x equals 9. That's our first step. And our second step is still going to be the same, but now we've got a base e. So log base e of 9 equals x. Remember that exponent always goes on the other side of the equal sign. And we could write this if we really wanted to as natural log of 9 equals x. And you can do that in your calculator. So there's an ln button somewhere in your calculator, I'm sure. And x would be 2.197. And the last problem here, we'll do the same process. I want to get this exponent by itself, so I need to divide by that 0.25. So divide by 0.25. And e to the x minus 9 equals 48. So that's just my first step. But now I need to write this. This needs to be written as a natural log, or just a logarithm base e. 48 equals x minus 9. And you know, we can simplify this in our calculators. So natural log of 48 equals x minus 9. And let me find out, what is the natural log of 48? It is 3.8712. And to get x by itself, I can add 9. So x would be 12.87. I'm just going to leave it as 12.87.